Assalamualaikum Doctor. I hope that Doctor and family always health and safe. Firstly, I'm Mahfuz bin Abdul Hamid from 4BMMD 1/1. From this subject, automotive component manufacturing. The car component that I had choose is crankshaft. The crankshaft is essentially the backbone of the internal combustion engine. The crankshaft is responsible for the proper operation of the engine and converting a linear motion to a rotational motion. For a manufacturing process, a crankshaft size Phillips induction is heated up to 2500 Fahrenheit or 1300 Celsius for forging temperature. A heated Phillips are placed into a giant press with forging die apply 150 to 250 ton of pressure. Afterward, the workpiece is clipped. The flash go to scrap bin. The crankshaft is transported to the next station, a twister, an operation in which 5 strokes of the shaft are properly aligned relative to one another by twisting. The forging process itself significantly compresses the grain structure of the forged crankshaft. It creates much more uniform grain structure compared to its cast part. And this means that forged crankshaft is typically not just stronger but significantly more ductile when compared to cast crankshaft. The final operation in producing a raw forging crankshaft is hot sizing. During this process, the crankshaft receives its required accuracy in form. The CNC machine shaved off several dimensions that was counterweight process. This process was slim it down for balanced performance. Turning machine drill a hole at one of the bearings to reduce a total weight. Next, the worker remove mark that the machine left on the metal. Fine glass bin is used to remove the sharp edge and give a consistent finish of crankshaft. The crankshaft spin in a lathe to remove a precise of metal to make a fine finishing surface. The crankshaft is taking another spin with sensor to detect any unbalance. Then measure the degree of straightness is made. If there are any unbalance, the worker use a special radius chisel. From this view, at the left is a pass on straightness and balance. We can see the difference of the structure. For simulation, click on New Study and click Static. Change the name to Crankshaft Force Test. Then OK. Next, select the product and apply the materials. I use it alloy steel as a material. Then apply a fixed geometry. I assume that a fixed geometry is at the end of the left and right side. Then apply a force. I select a 3 direction and Newton is 90.61. That convert from 2 kg. Assume that each piston is 2 kg. Then can run a study. So the result. So to bring a report. This report result. If you want to show animation, right click on stress and click on animation. So you will display the force motion. For compression test, select new study, static, and click OK. Then fix geometry, assume at the mid, then OK, and apply a force with pressure that end of left and right, and 19 Newton per meter. Then you can run study. Beside that, select material, alloy steel, and apply. Okay, you can run a study. This is a result from the simulation. That's animation. Then can generate a report. This is a report that I generate. Mesh, resist, stress, displacement, and a strain. That's all from my presentation, and thank you. I hope that the day stays safe.